Hello everyone and welcome to Synoptic Meteorology. We've already into the middle of the semester and we've covered quite a bit of material. We've gone through block 1, 2, and 3. We just finished kinematics and now we're working our way into dynamic meteorology. So our topic this time will be dynamics. And by definition, if you look at the glossary of meteorology, it says that dynamic meteorology is looking at the motions of the atmosphere and trying to come up with equations that describe that. So you thought you had enough of equations already. Here they go. We're really getting into them now. So another way of describing atmospheric dynamics is by, Howie Bluestein came up with this. Howie is a professor at the University of Oklahoma. And basically, if you want to summarize it, it's looking at forces and their motions. So we are going to look at atmospheric forces. And from that, we're going to come up with a way of describing an equation that describes the motion of the air. And then from that, we're going to work our way into the different types of winds, how wind flows through the atmosphere, and the forces that are causing it to go. So we need to jump into and examine forces, and this comes back to Newton. Newton, of course, lived in the 17th century and came up with some very pioneering concepts. One of them was Newton's second law, which stated that, if you want to summarize it, it says acceleration is equal to force divided by mass. In other words, the acceleration of a body, if there are forces on a body, the acceleration of the body is directly proportional to the forces that are acting on it and inversely proportional to the mass. So let's take a body. There you see a body. It's moving along at a constant velocity. Velocity means speed and direction. So it's unaccelerating. It moves along and a force is applied to the body. That force will result in a change in direction of the body. So we had a body that was moving along unaccelerated, a force was applied to it, and as a result we saw a change in the direction of that body. In other words, the velocity changed because of the force. So whenever we have a change in velocity, that means that we saw or experienced an acceleration. At least that body experienced an acceleration. So Newton's law says that you will have a resultant acceleration of a body which is directly proportional to the force that was applied and inversely proportional to the mass. So we need to take the mass of the body and divide it by the force, and that'll give us our acceleration. You've probably seen this equation before. Force is equal to mass times acceleration. In meteorology, the body that we're talking about is the air. The air is made of oxygen, nitrogen. It has mass. So what we're going to do is look at the forces that are affecting the air. In other words, what kind of forces are acting on the air? So here are the four forces we're going to talk about. We're going to start out with gravity, work our way into friction, and then spend some time discussing pressure and pressure gradient force, and then also finally an apparent force, which is Coriolis. So first, let's start out with gravity. We already discussed gravity when we were talking about hydrostatics, if you remember that. You remember the hydrostatic equation said that the vertical pressure gradient was balanced by the Earth's gravity. So the Earth's atmosphere has mass and gravity is acting on that. So we have a force which is the mass of the atmosphere times gravity, which is of course directed towards the center of the Earth. Another force that we have that we're going to talk about empirically is friction. or at least maybe we'll talk right now kind of qualitatively and not necessarily quantitatively. But friction is a force, of course, that retards the motion of the wind, and it acts in the opposite direction of the wind, and it is a force. And it's very important in the lowest layers of the atmosphere. We've come up with relationships that talk about friction and different types of surfaces. But it is confined to mostly, as I mentioned, the lowest part of the atmosphere. That's all we'll cover in this part, this first part. The second part, we'll start working our way into pressure gradients.